Picture this: 23 million years of ocean history, billions of predators, and out of all of them, one single animal has haunted human imagination more than any other creature that ever lived, dead or alive. We've built movies around it, museums around it, nightmares around it. And for 200 years, we've been picturing it completely wrong. Here's the part that should stop you in your tracks. In over 200 years of studying this creature, scientists have never, not once, found a complete Megalodon skeleton. Not a skull, not a full spine, not even one good ribcage. Everything we thought we knew about the biggest predator in the history of planet Earth was built on fragments, teeth, a few chunks of backbone, and a whole lot of guesswork borrowed from a completely different animal, the great white shark. For decades, that guesswork became fact. Documentaries, movies, museum models, that giant fiberglass megalodon jaw people take photos inside of. All of it was based on one simple assumption. Megalodon was basically a great white shark, scaled up to horror movie size. Same stocky, torpedo-shaped body, same blunt nose, just bigger. Much, much bigger. But here's the natural question nobody asked loudly enough. What if that assumption was wrong from the start? That question sat quietly in the back of paleontology for years, until a small stack of fossilized vertebrae, bones from the spine, started telling a very different story. And when scientists in 2025 finally sat down and reanalyzed everything with fresh eyes, they didn't just tweak the old picture of Megalodon, they tore it up. This is where our story really begins, not with the teeth everyone already knows about, but with a spine, specifically one incredible fossil dug. Up in Belgium, a nearly complete vertebral column stretching 11 meters long, about 36 feet, roughly the length of a school bus, missing only its head and tail. The specimen represents just the trunk of the shark, since its head and tail were never recovered. For most researchers, a fossil like that is a dead end. You can measure it, sure, but without the head and tail, how do you figure out how big the whole animal actually was? For years, the honest answer was, you can't. Not precisely. You estimate using a great white shark as your template, because that's the closest. Living relative anyone assumed made sense. That's exactly the problem an international team of 29 scientists, shark biologists, paleontologists, anatomists from across the globe decided to solve differently. Led by paleobiology professor Kenshu Shimada of DePaul University, this wasn't a solo theory from one lab chasing headlines. It was a coordinated, years-long reassessment, cross-checking fossil evidence against an enormous dataset, the body proportions of 145 living shark species and 20 extinct ones. Instead of assuming Megalodon looked like one specific modern shark, they asked a more honest question. Across the entire shark family tree, how do head and tail length typically scale against the trunk? And once they ran the numbers, something clicked into place that changed everything. Because here's the twist nobody was expecting. Megalodon's head wasn't small, like a great white's relatively blunt face, and its tail wasn't stubby either. According to the new proportional model, the head made up roughly 16.6% of Megalodon's total body length, while the tail accounted for around 32.6%, meaning nearly half the animal's entire length was head and tail combined, not the thick, muscular trunk everyone had been picturing. Apply that ratio to the Belgian fossil, and the math gets almost unbelievable. That 11-meter trunk alone implies a total body length of roughly 16.4 meters, about 54 feet, with a 6-foot head and a 12-foot tail attached to it. And that's before we even get to the largest individuals ever recorded in the fossil record, which, as we'll see in section 3, push the number even higher, into territory that sounds almost fictional. But size was never really the secret here, the real secret. The one that quietly rewrites Megalodon's entire biography is shape. Because if the head-to-tail proportions are different than we assumed, then the whole silhouette of the animal changes. Not a bulky, stocky brute smashing through the water like a runaway truck. Something longer, leaner, built completely differently, for a completely different way of hunting. And once you accept that Megalodon's body wasn't what Hollywood, museums, and even textbooks had been telling us for generations, you have to ask the next uncomfortable question. If it wasn't shaped like a great white, what was it actually built to do? How did something that size even move through open water without collapsing under its own mass? That question takes us somewhere unexpected. Not into the fossil record this time, but into physics, into the hard limits of what a body that size can physically survive doing. And that's exactly where the next part of this story takes a turn nobody saw coming. Let's slow down on that number for a second. Nearly half of Megalodon's body, head plus tail, wasn't the thick engine room everyone imagined. So if you strip away the Hollywood image of a bloated, blunt-nosed super predator, what are you actually left with? According to Marine biologist Philip Stearns, one of the researchers behind this reassessment, the answer breaks the old mental image completely. Rather than resembling an oversized great white, the new research suggests Megalodon was actually sleeker and more streamlined, closer in body plan to a lemon shark. Sit with that for a moment. A lemon shark, not a chunky ambush predator, but a long, torpedo-shaped cruiser, the kind of body built for efficient, sustained swimming rather than short, violent bursts of speed. That's a genuinely strange thing to picture at Megalodon scale, because everything about biggest predator ever screams brute force, and yet the math says otherwise. Here's where the story takes its first real twist, and it comes from an unexpected place: engineering. Specifically, hydrodynamics, the physics of how bodies move through water. Researchers didn't just ask, how big could Megalodon get? They asked, how big could an animal built like a great white physically get before its own body shape works against it? And the answer, it turns out, is a hard ceiling. Great white sharks, with their thick, stocky bodies, seem to top out at around 20 feet long, about 6 meters, before that body shape becomes too inefficient to move through water at any larger scale. Push a stocky body bigger than that, and the drag, the muscular strain, the sheer physics of shoving that much water out of the way stops making biological sense. Meanwhile, animals with sleeker, more elongated body plans, like blue whales, which stretch up to about 100 feet, 30 meters long, can keep scaling upward precisely because their shape doesn't fight the water the same way. So here's the puzzle that had been quietly sitting unresolved for years. Megalodon indisputably got enormous, far bigger than any great white ever has or ever could. But if it had a great white's stocky body plan, physics says it simply shouldn't have been able to. Something didn't add up. Either the size estimates were wrong, or the body shape assumption was wrong. It turns out it was the shape. This is genuinely one of the more elegant twists in the whole story, because it means Megalodon wasn't gigantic, despite the rules of hydrodynamics. It was built specifically to obey them. A longer, leaner, more streamlined frame is exactly the kind of body plan that lets an animal keep growing, past the point where a stockier build would physically fail. In other words, Megalodon didn't just happen to be the biggest predator in ocean history. Its whole body appears to have evolved as a solution to the very real physical problem of being that big. And this is where the story loops back to that old assumption everyone made for decades, that Megalodon must have looked like a scaled-up great white simply because their teeth look similar. Teeth tell you a lot about diet and bite force. They tell you almost nothing about overall body shape. It's a bit like assuming two people must have identical builds just because they both have the same size shoes. The team behind this new study leaned specifically into that gap, deliberately avoiding the assumption that sunk previous reconstructions. As lead researcher Jake Wood put it, what set this study apart from every previous attempt at reconstructing Megalodon's size and shape was moving away from relying solely on the modern great white as the template. That's not a small correction. That's a foundational rebuild of what this animal actually was, and once the shape changes, everything downstream of it changes too. How fast it could realistically swim, how it hunted, even how its babies were built before they ever left the womb. Speaking of speed, this same vertebral analysis let researchers estimate something that sounds almost mundane on the surface, but is quietly fascinating once you think about it. Based on the structure of Megalodon's fossilized scales, its estimated cruising speed sat somewhere between 1.3 and 2.2 miles per hour, roughly 2.1 to 3.5 kilometers per hour, which is, almost eerily, in the same range as a modern great white's normal cruising speed. So picture that for a second. An animal potentially over 15 meters long, gliding through Miocene oceans at a pace barely faster than a person casually swimming laps. Not because it was slow or sluggish, but because, at that size, efficient cruising was survival. Bursts of speed for an ambush, sure, when a meal presented itself. But day to day, a slow, streamlined, energy-conserving glide through open water, exactly what you'd expect from a lemon shark-shaped body rather than a great white-shaped one. We now have a very different animal in our heads than the one we started with. Longer, leaner, built for efficient, sustained cruising rather than blunt force ambush. But we still haven't answered the one question everyone actually clicks on a Megalodon video for. Exactly how big did this thing actually get? Because the number that comes next isn't just bigger than people expected, it's bigger than nearly every previous scientific estimate combined. And it comes with a detail about how Megalodon babies were born that is genuinely unsettling. Here's a fun bit of scientific whiplash. In 2019, Kenshu Shimada, the very same lead researcher behind this new study, published a paper concluding that Megalodon topped out at around 15 meters, roughly 50 feet long. At the time, that just 50 feet figure was treated as the responsible, conservative ceiling, based on the assumption that Megalodon shared a great white's proportions. 6 years later, the same scientist, armed with a completely different method, came back with a very different number. Once the head-to-tail proportions were recalculated using that broader data set of 145 living and 20 extinct shark species, the Belgian trunk fossil, that 11-meter headless, tailless spine, implied a total length of about 16.4 meters or 54 feet. That's already bigger than the old 2019 estimate, but it isn't even the ceiling. Because Belgium isn't the only place these vertebrae have turned up, researchers also examined comparable fossil vertebrae recovered from Denmark, and this is where the twist lands. The largest vertebra from the Belgian specimen measures about 15.5 centimeters in diameter, but separately reported Megalodon vertebrae from Denmark measure as much as 23 centimeters across, nearly 50% larger. Run that Danish measurement through the same proportional model, and the number that comes out the other side is almost hard to say out loud. If those Danish vertebrae belong to the largest part of that individual's body, the animal could have measured roughly 24.3 meters long, about 80 feet. 80 feet. Let that sink in against something familiar. That's longer than a standard American school bus and a half. It's close to the length of a Boeing 737 fuselage. It's the length researchers behind the Western Australian Museum's parallel analysis independently arrived at too, describing a maximum plausible size of up to 24 meters long and roughly 94 tons in weight. Some 4 to 9 meters longer than earlier estimates had suggested. 2 separate research efforts using different fossils and slightly different methods, converging on almost the exact same jaw-dropping number. That kind of independent agreement is exactly the sort of thing that makes scientists sit up. It's not one lab chasing a viral headline. It's multiple approaches landing in the same neighborhood. Now, here's an important honesty check, because good science always includes its own uncertainty, and that's actually part of what makes this so compelling, rather than sensational. The researchers themselves are careful to flag that this 80-foot figure represents the upper edge of what's currently reasonable, not a confirmed, guaranteed measurement. As the study's authors put it, 24.3 meters is currently the largest possible reasonable estimate for Megalodon, not a settled final number. Science doesn't deal in Hollywood certainty. It deals in, here's our best model based on the best evidence we currently have, and here's exactly where the uncertainty lives. That honesty is, frankly, more impressive than a fake certainty would be. But size wasn't the only bombshell buried in these vertebrae. Bones like these don't just record length, they record growth. Layer by layer, like tree rings, a shark's vertebrae can preserve a record of how fast it grew and how large it was at different life stages. And when researchers read those growth rings backward, toward the very beginning of a megalodon's life, they found something genuinely startling. The fossilized growth patterns suggest that baby megalodons were already massive at birth, somewhere. Between 12 and 13 feet long, about 3.6 to 3.9 meters. That's not a typo. A newborn megalodon pup, fresh into the world, was already longer than a fully grown adult human lying down twice over. Longer than most adult great white sharks swim around as fully grown adults today. How does an animal get born that enormous? This is where the twist gets genuinely uncomfortable. Like several modern relatives, including great white sharks, Megalodon embryos likely engaged in a brutal survival strategy inside the womb. Intrauterine cannibalism, where developing embryos consumed unfertilized eggs, and, in some related species, weaker siblings, to fuel their explosive growth before ever being born. Before a baby megalodon ever took its first bite of prey in the open ocean, it had likely already survived its very first competition for survival, inside its own mother against its own siblings. Only the biggest, most aggressive embryos made it out, which means every single megalodon that ever swam free in prehistoric oceans had already won a life or death contest before it was even born. That single detail reframes the entire animal. This wasn't just a big shark. It was an animal engineered for dominance at every single stage of life, from the womb onward. Genuinely massive at birth, streamlined for efficient long-distance cruising as an adult, and capable, at its outer limit, of reaching a length that dwarfs nearly everything that has ever hunted in the sea. So if Megalodon was this efficient, this well-adapted, this dominant from birth to full maturity, the next question is the one that's been sitting under this entire story the whole time. If it was such a perfectly engineered predator, why isn't it still out there? What actually took down the most successful hunter the ocean had ever produced? And the answer connects directly back to everything we just learned about its body, in a way that closes this story with a twist that feels almost poetic. Let's be completely clear about one thing before we go any further, because this is the point where a lot of channels lose credibility chasing clicks. Megalodon is not out there. It is not hiding in the Mariana Trench. It did not survive into modern oceans. no matter how entertaining certain documentaries and mockumentaries have. Made that idea sound, Megalodon's extinction is settled scientific fact, with its fossils dating between roughly 15 and 3.6 million years old. There is no secret population. That mystery isn't real, but here's the mystery that is real, and it's arguably more interesting. Why did an animal this dominant, this perfectly engineered, disappear at all? This is where everything from the last 3 sections quietly comes back together, because the same body plan that made Megalodon so successful may also explain exactly why it couldn't survive when the world around it changed. Remember that streamlined, lemon shark-like body built for slow, efficient, long-distance cruising? That body plan is a phenomenal solution for one very specific lifestyle, patrolling vast stretches of open ocean, hunting large, energy-rich prey, like ancient whales, and doing it as efficiently as possible over enormous distances. It's an animal built like a long-haul cargo ship. Enormously powerful, incredibly efficient at what it's designed for, but not built for sudden, dramatic change. And around 3.6 million years ago, the ocean changed dramatically. Global climates were cooling, sea levels were dropping. The rich, warm coastal waters that once supported enormous populations of large whales, Megalodon's primary prey, were shrinking and shifting. Many of those ancient whale species were themselves declining or going extinct during this same window. At the exact same time, a newer, smaller, faster kind of predator was rising fast in the very same waters. The modern great white shark, along with other emerging apex predators, better suited to a cooler, more variable ocean and a wider, more flexible diet. Here's the twist that ties every earlier section together. The same physical efficiency that let Megalodon become the largest predator the ocean had ever seen. That lean, elongated body, built for endurance, cruising rather than rapid adaptation, may have become a liability the moment its prey and its environment shifted underneath it. A body engineered for cruising through stable, prey-rich open ocean isn't necessarily a body that can pivot quickly towards smaller, more scattered, more elusive prey in a rapidly cooling world. Great whites, smaller and more metabolically flexible, could adapt to hunt seals, smaller fish, and more varied prey across changing coastlines. An animal the size of Megalodon, needing an enormous, steady caloric intake just to survive, had far less room to adjust. In other words, and this is genuinely the most quietly devastating part of the whole story, Megalodon may not have gone extinct despite being perfectly built for its world. It may have gone extinct because it was so perfectly built for a world that was disappearing out from under it. Specialization that looks like strength in a stable environment can become the exact same trait that dooms a species when that environment stops being stable. That's not just a Megalodon story, that's a pattern echoed throughout the entire history of life on Earth. And this is precisely why the 2025 reassessment matters so much more than the shark got bigger. Here's a cool number for a thumbnail, because no complete Megalodon skeleton has ever been found. Every reconstruction of its body shape, length, weight, and behavior remains an estimate, one that stays genuinely open to revision as new. Fossil surface. What changed in 2025 wasn't just a bigger tape measure. It was researchers finally, deliberately breaking free of the assumption that had quietly limited every previous study that Megalodon simply had to resemble a great white shark because their teeth happened to look alike. That's the real secret buried at the heart of this whole story. Not a hidden Megalodon lurking in some unexplored trench. Not a number on a chart. The secret is that for nearly 2 centuries, we'd been looking at fragments of the biggest predator in ocean history and unconsciously forcing those fragments into the shape of an animal we already knew, simply because it was familiar. The moment scientists let the fossils speak for themselves, comparing Megalodon against the entire breadth of shark evolution rather than just one modern cousin, an entirely different creature emerged from the same bones people had been studying for 200 years, longer, leaner, built for efficient, relentless cruising rather than brute, stocky force. Enormous from the very moment of birth, and ultimately undone not by weakness, but by a changing world that no longer had room for an animal built so completely, so efficiently for the one it used to rule. That's the real story hiding inside those Belgian and Danish vertebrae. Not a monster. Resurrected, but an entire extinct giant, finally seen clearly for the first time in millions of years.